Hi, everyone. My name is Shay Keinan, and today we are going to talk about React 360. A bit about myself. I'm a software developer at a company called 500 Tech. I work mainly with React and React Native. I provide consulting services and teach various courses such as React, Advanced React, Redux, CSS, and data visualizations. I'm one of the organizers of React Next, a React conference in Tel Aviv. And I hope that you will join me maybe next year. Today, I'm here to talk to you about React 360. We will start with the basic concepts of virtual reality, learn how to get started with React 360, and learn a new approach for integrating 3D views into React.js. By the end of this talk, you will know when to use React 360 and how to do it, and how to get started with Three.js and develop 3D experiences in your web browsers. Virtual reality is being used in many industries. Besides games, VR is used in fields such as medicine, education, movies, architecture, travel, military preparation, retail, and much, much more. Because of its ability to completely immerse you in a scene, the possibilities are endless. It all goes back to something called lucid dreaming. A lucid dream is a dream during which the dreamer is aware of dreaming and can do anything, even fly. The first known mention of lucid dreaming was in the ancient Sanskrit text of Mandayuka Upanishad around 500 BC. Then, around 415 BC, St. Augustine presented to us the first well-known report of lucid dreaming. He shared the story of a friend who dreamed he was hanging out a guy in heaven, and the guy kept reminding him that he was actually asleep. In 1838, Charles Wheatstone invented the stereoscope. He found that if you put two slightly different images next to each other, the brain can turn them into a 3D image. This brought up something called virtual tourism. For the first time, people could actually see and experience places they've only dreamed about. In 1935, Stanley Weinbaum released Pygmalions Spectacles, a story about a pair of goggles that can let a person feel like they are in a fictional world. This story is considered the first comprehensive model for virtual reality. For the next several decades, we got things like the Sensorama, the ultimate display, NASA's visual environment display, Sega VR, and the Nintendo Virtual Boy. Finally, in 1987, Jaron Lanier invented the term virtual reality. And since then, we've had things like Google Cardboard, Google Daydream, and the Samsung Gear VR, all of which are very basic and affordable devices. Then we got the Oculus Rift, the HTC Vive, and the PlayStation VR that gives us a rich experience, but with an expensive price tag. Those devices require external computing power and external tracking sensors, and as a result, they are not portable. Computing systems of all sorts are getting smaller, cheaper, and much more efficient, and virtual reality is no different. A couple of standalone VR systems will arrive next year, and they will be able to advance virtual reality as a mainstream consumer technology. One of them is the Oculus Go that was already released this year, a couple of months ago. The Go is offering a standalone experience, but without positional tracking, meaning that the user will always be at the center, but with a 360-degree views. Oculus is also working on two different standalones, the Oculus Santa Cruz and the Oculus Quest that will be released early next year. Those headsets will offer positional tracking using on-headset trackers and something called 6 degrees of freedom, meaning that the headset recognizes your hand movement and you can touch and grab things within the scene. These headsets are a big step towards virtual reality becoming a true mainstream technology. So now, after understanding how it all started, we can talk about virtual reality concepts, things that we as developers must know if we want to build a virtual reality application. So what is virtual reality in a nutshell? Visual virtual reality is made up of two things: stereoscopic imaging and movement tracking. So let's take a look at these two images. Are they identical? They seem identical, but if you look closely, you can see some differences. I've highlighted one for you. Can you notice the figure on the background on the right? Stereoscopic images are based on how the human brain works. It takes two images that show the same content, but from a slightly different point of view. The offset of these images corresponds to the distance between our eyes. This distance is called Interpupillary Distance, or IPD for short. In this way, we simulate the way we see the world naturally, and it gives us the perception of 3D depth. Headset lenses are an integral part of the virtual reality experience. And why do we use headset lenses? Because they position the images on the screen at the exact distance that they need to be to get the desired effect, the stereoscopic effect. But VR lenses are thick, so they cause a distortion. The square that you see on the left looks caved in through the lenses. The outcome looks like what we see on the right. So to compensate for this, we give images that are rounded out. On the left, you can see the compensated image before the lenses, and on the right, this is the final desired image. So to sum up stereoscopic imaging, by showing two slightly different images to each eye using special lenses, we get the effect of depth. Besides stereoscopic imaging, the second thing we need to complete the illusion of virtual space is to track the movement of our body. All VR devices track head movement, so we can look around. Some devices, the more expensive ones, track body movement, so we can move around, we can walk around the scene. Of course, the more tracking sensors that you have, the better the illusion of reality. Last year, Facebook announced the launch of React360, a new JavaScript framework based on Three.js and React Native. React360 allows developers to build virtual reality experiences with the help of JavaScript. As the name implies, React360 uses the same concepts as Facebook's existing React framework. Just like with React for standard web apps, VR developers can now use the same declarative model to write apps for their 360-degree experiences. Just like in animation, VR apps need to be rendered at 60 frames per second, and this is something that React Native has already solved for us. It's important to know, again, that React360 is based on React Native and Three.js. Most of the components that we use are React Native components, and the 3D rendering engine is the Three.js rendering engine. For those of you who are not familiar with Three.js, Three.js is a cross-browser JavaScript library used for displaying animated 3D graphics, invented around 2008 by Ricardo Cabello. He decided to write a JavaScript abstraction for Webgl, and since then, this is the leading library for those experiences. So now let's take a look at some Three.js examples from the web. Pretty cool, right? And everything is working here at 60 frames per second in your web browser, and sometimes even in your mobile browsers. So let's get started with React360. First, we'll begin by installing the tool that we need. We will install React360 CLI. This is a generator, just like Create React App or Create React Native App. And we are going to initialize our project by running React360 init, the name of our project, In this case, it's Allow360. This will install all of the dependencies that we need in order to run the project. Then we are going to run npm start and open our browsers. Facebook already created a very basic Hello World project, which they call Allow360. And if everything went well, you should see the following. We have a basic scene with a panoramic image of stars. And in front of us, we can see a text component with the text, with the sentence, "Welcome to React360." After the init, we get the following file structure. All of the static assets are located in the static assets folder. So if we want to load 3D models, textures, images, sounds, this is the right place. The entry point for our application is the index.vr.js file. And there is also a file called client.js used for the application configuration. And this is the entry point for our application, basic React component that contains 2 views and a text component with the sentence, "Welcome to React360." And on the bottom, we register this component just like any React component, just like in React Native or React for Web. Now let's begin building our own application. The app that we are going to build together will present our solar system planets. You can use the link on the screen to try the demo right now on your mobile phones or your laptops. It's bit.ly/solardemo. And this is what the application is going to look like. We can see a planet with some text. There is a menu on the right to change to another planet. There is some animations as well. And if we will look to our left, there is some additional information about each planet. To know where to place objects and how to move around the scene, we need to be familiar with the coordinate system. The coordinate system is the same as Opengl coordinates, meaning that y positive is up, and we use the right-hand rule for rotation. We can apply different transformations on any component, just like we do with CSS. The syntax is a bit different than classic CSS, but should be familiar to those who code in React Native. So for example, if I want to place an object anywhere other than 0, 0, 0, I will use translate. If I want to change its size, I will use scale. And if I want to rotate it along a certain axis, I will use rotate, just like in CSS, translate, scale, and rotate. Just like React Native, React360 provides a set of basic primitives used to construct user interface. This is a powerful feature of React360. Developers can use the same styling and layout system across web, React Native, and VR, which opens the doors to directly sharing layout styles across these platforms. Vue is the most fundamental component for building a UI. Vue is a container that supports layout with Flexbox, style, and touch handling. Vue maps directly to the native Vue equivalent on whatever platform React Native is running on, whether that is a UI view, a div, an Android view, etc. Vue is designed to be nested inside other views and can have 0 to many children of any type. Text, this is a React component for displaying text. Text supports nesting and styling as well. And image, a React component for displaying different types of images. But keep in mind that you must manually specify the dimensions of your images. Here in React360, image dimensions are specified in meters. And it's not possible to predict the intended dimensions from the pixel width and height of the original image. So now let's go back to our solar system app and add a panoramic image. You can create panoramic images or videos by using a special 360 camera, or even nowadays using your mobile phones. If you only need to set the background once during your application lifetime, this is the easiest way to go to the client.js file and to set the background. Here you need to provide the path to your image. But if your background is dynamic, such as in a multi-room environment, you'll want to control it from your React application, from your components. And this is possible through the environment module. You can just import it from React360, and again, set the background, and you need to provide the path to your image. So this is my JPEG. Now, let's see what it looks like in 3D. This is the result. We can see that we are inside the sphere. Our sphere is the cosmos. The image is surrounding us. So that was the way to load panoramic images or even videos. Now let's talk about the Flexbox layout system. In React360, we can lay out components in 3D using Flexbox. The library used is CSS layout, and the syntax is more or less identical to the web Flexbox. But as you can imagine, using Flexbox to lay out content on a 2D plane is not optimal for the 3D experience. So it's a common practice to lay out the content on a cylindrical plane, and this will give us a 2.5D feel. So in our application, I created a menu to navigate between planets. This is our menu declaration, a basic React component. And we can see that we have a view that contains other views, one view per planet, and we can also see a text component with the name of the planet. And this is our menu, a view with 9 views inside, one for each planet. So we built a menu for navigating among the planets, but now we want to make it clickable. In VR, we interact with objects in a different way than the web. We don't necessarily click on something. It may be enough that we look at an object for a significant amount of time in order to trigger an event. Other than looking, we can also press a controller in order to trigger a reaction. To make our scene interactable, we are going to use a component from React360 called VR button. This is a helper component that manages the interaction state machine. By default, a VR button has no appearance and will only act as a wrapper to capture events, but it can be styled in the same ways as a view. So when pressing a button in our menu, we're going to update our state with the new planet. And let's take a look at our menu again. Now when we press a button, we are updating our state, and as a result, we can see that the header component updates with the new planet name. Next, I want to talk about loading models. There are many types of model formats available out there: OBJ, STL, Collada, C3D. They may come with a built-in animation, they may come with a material or with texture. At the moment, React360 supports two file formats, the wavefront OBJ and the GLTF. So under the static assets folder, I have created a folder for models and a folder for textures. What are textures? They are images, PNG or JPEGs that wraps our 3D model with UV mapping. React360 provides a component for loading models called entity. So let's try to load Earth. Here is our planet declaration, and we can see that we need to provide a property called source. We need to provide our 3D model. Here, in this case, it's the OBJ, and also a material, and this is optional. Keep in mind that we are using here a utility called asset. This is a utility from React360 that will load assets for us straight from the static asset folder. And here is the loaded model. We can see that by changing the current planet, we're causing a new model to load every time. To make our scene more interesting, we can add animations to objects and layouts. There are many ways to create animations in React360. For example, using the animated library or any third-party library for JavaScript animations, or manually with request animation frame. So this is an example of request animation frame. What I want to do here is rotate a planet. The rotate function in this example is called in a loop, hopefully at least 60 frames per second. And on each call, we are advancing the rotation by a delta. And this is the result. We can see that the planet is rotating. And if we switch planets, the new model will still rotate around itself in the same way. Now let's see an example of how to use the animated library for animations. So when a button is pressed, we want to make it look like it bounces a bit. And also, when a new planet appears, we want to give it a nice little bounce. In the animated library, this effect is called spring, a spring effect. And keep in mind that the animated library is built in React360, just like React Native. You can just import it and use it. Now let's look at the bounce effect, at the spring effect. When we click on a menu button, we can see a bounce. And also, the new model, the new planet, appears with a bounce, with a spring. And here is our final application. We are inside a panoramic image where we loaded an image of stars. We can see the header component with two texts inside. Below, that is a loaded model where we used the entity component. On the right, we can see a menu. A click on a menu item will switch to a different planet with a bounce. The menu button also has a spring to it. And on our left, we can see some additional information about the planet. As I mentioned before, React360 is based on Three.js, but only uses a portion of its features. The main feature of React360 is the ability to create user interfaces in 3D. But when we want to develop complex 3D experiences and dive deep into Three.js, we need to do some hacks or try to extend React360 to include those capabilities. In order to use different materials, lights, and shaders to access the different properties of an object or manipulate it, we need to extend React360, and as a result, we're always trying to keep both of the libraries in sync, and this is too difficult for us. So now I want to show you a different way. If we don't care if the user interface itself is in 2D, and we want to focus on the 3D content, we can split the UI from the 3D content, so all of the UI is a plain React, and all of the 3D content is Three.js. We're going to create a separate class that controls the Three.js scene. Now let's take a look at such a class and learn how to initialize a basic Three.js scene. Here in our class, in the init function, we are getting a reference to an element that will hold the Three.js canvas. We're creating a new perspective camera and a WebGL renderer. And on the bottom, we are calling the animate function. This will create a loop that causes the renderer to draw the scene every time the screen is refreshed. On a typical screen, this means 60 times per second. And that's it. From this point, Three.js is fully integrated, and we can manipulate the scene easily. After splitting React and Three.js, we can use different loaders. Unlike React360, which only supports the OBJ and the GLTF file formats, now we can load different file types that Three.js supports, like STL or Collada, or like this file format that comes with a built-in animation. And we can also use different materials and control their properties, such as metalness or roughness. We can load to the scene different lights that will affect our objects, such as ambient light, directional light, spotlight, hemisphere light, and many, many more. Now we can access the actual model and manipulate its geometry. The geometry is basically a set of points that define the model's vertices and faces. And here, with a very simple for loop, I'm rotating each vertex according to its height, according to its Y position. To make the scene more realistic, we can add third-party libraries that simulate physics. This will add to our scene gravity, collision detection, friction, forces, and much, much more. Because we have access to the render loop, now it is easier to animate objects. In this example, I'm getting input from the device's microphone, and I'm controlling the cube's Y position. It's also easier now to integrate different controllers that affect our scene, such as lip motion or Vive controllers. But if we still want the VR experience, we need to add 3 things to our scene. The first is the WebVR polyfill, a JavaScript implementation of the WebVR spec that will work on any platform. Second is the VR controls that will allow us to look around the scene using our headset. And lastly, the VR effect. This will give us the stereoscopic vision that I mentioned in the beginning. React360 is relatively new and lacks some of the core features of Three.js. For a very basic project that relies primarily on layout, I suggest using React360. But for projects that use advanced features of Three.js, I would instead recommend integrating Three.js into React on your own. This will give you much more flexibility and access to the full range of features that the library offers. I hope that you found this talk instructive, and I'll be more than happy if you share your future experiences with me. Thank you very much, and enjoy the rest of the conference.
Thank you very much. We've got a couple of questions for you. We only have a very short amount of time. What do you think about WebAssembly for 3D?
I don't have much experience with WebAssembly, so I can't answer that yet. But maybe I will check that, and we can talk about it after this talk. All right,
sounds good. Next one. Do you think AR has a stronger future versus VR?
I think that AR and VR are completely two different experiences, because in AR, augmented reality, you can see the real world with some manipulations. And in VR, you are in a different world. So you can't compete. You can't compare between the two of them, because they are two different experiences.
Mm-hmm. All right. Danny, a bit of self-promotion there. I like it. Does React360 on React Native work with Google Cardboard?
Yes, if you use WebView. React360 is not native. The output is a web application. So you can use the WebView to inject it into React Native.
Mm-hmm. All right. How does the Three.js WebGL implementation perform on mobile comparing to native OpenGL ES solution?
Of course, that OpenGL will be better than Three.js. For us, web developers, we can use JavaScript, and we can, with ease, create 3D applications for the web or even for VR. So the performance will be a bit slower, a bit with some lags. Of course, OpenGL, the native approach will be better.
Mm-hmm. Next question. Aussie in Prague, g'day mate, where are you at? Is it possible to use UI libraries like Semantic Ui or Material UI with React360, or does it only support 3D materials?
You can't use it. You can just use the view, text, or other basic components that React360 provides. But if you want to use React as the UI, as the interface, as one layer, and Three.js, let's say in the back, as the 3D engine, you can use whatever you want. If you want to lay out the content on a 3D way, you can do it using other libraries, with other libraries.
Okay, our next question. How does React360 compare to A-Frame?
A-Frame uses Three.js. Here, with React360, we can use React, something that we don't have in A-Frame.
Right. Do you have any idea where VR technology can be used in the digital media company?
Maybe in showrooms or, for example, there is some usages in hotels to show rooms, things like that. Maybe for an example, Caterpillar, to present vehicles, very large vehicles. You can switch between the parts, and it's easier to do that with VR, with virtual reality.
Mm-hmm. Okay, what does a texture image look like?
It's like a UV mapping. It's like a regular image that if you take a sphere and you try to open it, so something like that.
All right, maybe time for one or two more questions. Is there any physics library compatible with VR360? For example, Canon.js?
Yeah, you can use Canon.js or Emo.js or Fizzy.js with Three.js. There is no problem.
All right. Is it possible to change the FOV in React360?
I'm not sure, but in Three.js you can. So if you will take the second approach that I showed you, you can do that.
All right, getting through a lot. Is it now possible to write VR games in React Native together with React360?
Yes, but very basic games, very, very basic games. Because you don't have all of the features that you have in Three.js. So very basic games, let's say games for kids will fit this.
All right, very last question. All the static files for the 3D objects are usually large. How do you tackle performance, caching, memory, battery, data consumption, etc.?
So of course, if you want to load 3D models in the web, you will need to use smaller files, let's say for the web, for laptops, desktop, 5 megas or 10 megabytes. And you can create different versions of those files for mobile versions. Let's say with less polygons, so it will look less nicer, but it will work faster.
All right, thank you very much, Shay. Let's give him a round of applause.